Alright, moving on with 9.2, solving by the substitution method. Looking at problem number 3 here, I hope you would all agree that when you see this problem and see all those fractions, you probably realize it's going to be a little more tedious to work with this problem. It wouldn't be one where I would most likely choose to use the substitution method, and I would maybe use some technology in using Desmos or my graphing calculator using the matrices method. But you are supposed to be able to handle these with the substitution method, so we'll take a look at that. Now there's kind of a lost art that is taught in algebra about removing fractions or rewriting equations without fractions. And what we need to do is look at these denominators here in this first line and find the LCD, the least common denominator. And the least common denominator is 6 here. So what I'm going to do is I'm going to multiply every fraction by 6. And you can put in a 6 over 1, 6 over 1, 6 over 1. And what I'm going to do is I'm going to get my new line 1, okay? It's going to be the same equation in a different form. It would make the same line. So when I multiply this fraction by 6, and you could use your calculator, I get negative 10x. Here I'm going to get plus 9y. And then on this the right side of the equation, I'm going to get 3. Okay. Now looking at the second line, I'm going to form new line 2. Okay. You could work with the fractions, but I think it would be a big mistake. It's just a mess. My LCD on this side is 18, so I'm going to multiply everything by, or on both sides is by 18 over 1 to eliminate the fractions. Here I get 10x. Here I get minus 9y. And on this side I get minus 21. Okay. So at this point I'm still not ready for the substitution method because I have to get one of these equations in the form x equals or y equals. Okay? And so what I'll choose to do is I'm going to get line 1 here. I'm going to get this into y equals form. So if we think about it, I'm going to have to move this negative 10x over. So I have 9y equals 10x plus 3. And then I divide by 9. Okay, and you see I have a kind of a mess here. 10 ninths x plus 1/3, which isn't the most fun value to substitute in to my other equation. So I'm going to take this here and I'm going to substitute it in for y in my line 2. And you can see this is quite a messy problem, but I'm going to stick with it here. I got 10x minus 9. Remember, I'm just substituting in for the y. 10 ninths x plus 1/3 equals 21. Now this problem is going to get a little nicer in just a second here. When I multiply, and we got to be careful here, this is my coefficient in front of this parenthesis here, so I'm going to multiply everything by negative 9. Okay? Multiply everything by negative 9. What's going to happen here is I get negative 10x, and I'm going to get negative 3 equals 21. And like I said, this problem is going to get a little easier right here because this is 0, and I have 0 minus 3 equals 21. I have negative 3 equals 21. That's a false statement. Okay. Now, the word I kind of associate with false is the word no. Like, no, that doesn't work. And that leads me to think, okay, which type of my 3 cases is this? Okay, which type of my 3 cases is this? And if we take a look at Desmos here, we see that the lines are parallel. Here's the two original equations, and the lines are parallel, and what that means then is no solution. Parallel lines, okay? So that's one of the strange cases when you end up with something weird at the end here when you're solving by substitution and there's no variable left, okay? And now real quick, I have a little space over here. I'm gonna show you, if you were working a problem in substitution, okay, and say you're working down and you're working down and you're working down just like we were over here, and you come up, all your variables can cancel out and you come up with some type of equality like this. Not a false statement, but you see there's no variables here. So we're working out and we would have got maybe 21 equals 21 here. We'd hopefully realize that's a strange case and there's no variables present, okay? And this is always true, okay? 7 equals 7. And so I kind of think of that, okay, this is always true. And what kind of associates with always? That leads me to the logic infinite solutions. All right, so we have this strange case where we get inequality, where these aren't equal to each other, okay? And then we write no solution, and we might get a strange case where we get equality, and it doesn't have to be 7 equals 7. It could be any numbers there, okay? So if you do see those strange cases when you're working with substitution, remember that you have to go back and either look at it in Desmos, or you might put a little time thinking into, you know, which of these strange cases is it? Well, is it the no solution or the infinitely many solutions? Okay, that wraps up number 3. Kind of a long problem, but hopefully it was helpful.